All right, so for the last few lectures, I've basically been introducing you to how Java works, what the constructs are within Java that you can use, et cetera, et cetera. Starting today and for the next few problem sets, we're going to kind of switch directions, and basically all of the features of Java that you need to know, you already know. We've covered classes, we've covered inheritance, we've covered interfaces. So for the next few sections, we're just going to be talking about how to use those constructs efficiently and effectively, primarily focusing on some design patterns. So design patterns are basically agreed upon strategies that should be used in particular situations. And it also, some added benefits of design patterns is it makes it easier for us to talk about our code. Instead of having to explain step by step, I can tell you I'm using such and such design pattern, and you'll immediately know what I'm talking about. These design patterns came from a very famous book written by the Gang of Four back in the mid-90s, which is an excellent textbook, still referred to today. So I would highly recommend getting your hands on a copy if you're interested in learning more about these. You can find a lot online as well. The first pattern that I'm going to introduce to you today is the strategy pattern. And so the strategy pattern is used when you have multiple ways of accomplishing the same task. So it's common, it's very commonly the case that we have many possible ways of doing the same thing. Some ways are better in certain situations, and other methods are, of course, better in other situations. And so it's nice to be able to have a way of switching out the behavior of a program based on the situation. And that's what the strategy pattern really allows us to do. So the way that it works is we're going to use an interface. We talked about interfaces on Wednesday. Today we're going to use the strategy pattern to play rock, paper, scissors. So there's many different ways to play rock, paper, scissors. We're going to use the strategy pattern to come up with some ideas, to come up with some different ways of playing rock, paper, scissors. It's an illustration of how to use the strategy pattern. So our interface is going to be fairly simple. To play rock, paper, scissors, you basically have one thing you have to do. You have to choose a move, right? So our interface will have a simple method. I'm sorry? I haven't gotten to the actual strategies yet. That'll be next up on my list, though. Yeah, right now I'm just defining an interface. So what is the common behavior that all strategies are going to have, right? What are all of my strategies going to be able to do? And in this case, we'll say that all of my strategies can give us the next move, which will be one of three choices, right? Rock, paper, or scissors, right? So our interface in this particular case is going to be very simple. The next thing that we have to do, this interface, right, does not actually do anything. It's like a contract. So let's fix that. Let's create some stuff that will use this interface, create a couple of classes. Let's see, what's a good rock, paper, scissors strategy? I'm going to create one called the rock strategy. How do I use that interface? What do I have to type? Implements, thank you. And again, IntelliJ is mad at me. We saw this on Wednesday because I need to implement that method, right? And this strategy is going to be very simple. This person is very fond of rocks, so they're just going to play rock every single time. I can't think of any real properties that I need here, right? I can't think of any real instance variables that I need for this particular strategy to work. So in terms of a constructor as well, I'm not sure that I even need to create one. This is kind of a special case. You might see this from time to time. There's actually what's called a default constructor that's included with every Java class that doesn't take in any input arguments. It just gives you back basically a blank instance of this particular object. So, in this case, I'm going to say I don't think I really need a constructor in this case. I think the default constructor is appropriate since this is not a particularly complex class. So I'm done. Here's one strategy, right? Let's make another strategy that's a little bit more complex than this one. Let's do a random strategy that chooses one of the three options at random. Implement my interface. Okay. And this time I want to choose one of those three at random. So I'll have to pick a random value. I'll say, have you guys, I haven't discussed random values with you guys, although you have seen them in some of the tests and stuff that I've given you, right? And you probably saw them in CS50 too, is that right? Yeah, okay. So I'll just create a double math.random is how we do random numbers in Java. This gives me a value between 0 and 1. And so then I just need to somehow chunk that up into three different possible choices. I'll just use an if statement for that. If x is less than 0.33, turn rock. Else if x is less than 0.66, turn paper. Oops. Else turn scissors. Oh, I forgot a bracket. There we go. I'm sorry? Yes. So the question is, do I need to put an x is greater than 33 here? Consider when I execute this if statement, right? If x is less than 33, then I'm done. It's going to execute this and I'm out. If you wanted to make it clear, then absolutely. I mean, you can put this in. It's not going to hurt anything. Probably want to say greater than or equal to, just so what if it's exactly 0.33, right? That's fine. That's fine. So now I've got two strategies, right? I think that's enough to illustrate my point. We can create more strategies later, perhaps. So far I've created an interface to define the behavior that I want my strategies to have. I've created two concrete strategies that implement those interfaces. Now I want to create something that's going to use these strategies. So in our example of rock, paper, scissors, a player will use a particular strategy, right? So let's create yet another class. It's going to implement, or not implement, that's going to utilize these strategies. So here's my rock, paper, scissors player. This time I am going to make a constructor. And the final piece of the strategy pattern says we need to have a way of passing a strategy into the class that wants to use it. The way that we can do that, notice we have two strategies in this case. We could have as many strategies as we want, right? There's no limit on how many classes I create that implement this interface. But I want to be able to pass in a rock strategy for one player, and I want to be able to pass in a random strategy to another player, and maybe pass in a third strategy to a different player. How can I say that in the constructor? How can I write this constructor that will take any of those strategies? What can I say? Do you understand the problem? If I say rock strategy here, then I am bound to that. I have to use the rock strategy. Or if I say random strategy here, I have to use a random strategy for this particular player. How can I make this more general? How can I make this accept any of the strategies that I want? The interface, yes, thank you. That's exactly right. I can put the interface here, right? The interface. The interface is simply defining the behavior for these players. Get next move. So I can accept anything that implements that interface, right? Anything. And so what I'll do then is create, along those same lines, I'll create an instance variable. Oops, sorry. Need to create this as a private variable here. And then I will simply store the strategy in that instance variable, right? And so now when the player wants to get its next move, what's it going to do? It's going to consult the strategy. It's going to consult the strategy that I used to create this particular player. So again, I'll say, I'll create a method called next move, right? And it's not, oops, what do I want this return type to be? It'll be a string. And it's not going to generate the next move itself. It's going to refer to the strategy that I passed to it. So I'll just say strategy.getNextMove. I want to return that value. And so this is the final piece. We've successfully implemented the strategy pattern. Kind of three pieces if you've been following along, right? The first is the interface that defines the access to the strategy via methods, one method or multiple methods, whatever the case may be. Then however many classes I need that implement that method in various ways, right? That actually define the behavior itself. And then finally, a class that accepts the interface and stores it, and then uses that interface instance to dictate its own behavior. So we've successfully decoupled the behavior of the player from the actual player itself, right? We've taken that behavior, we've kept it entirely separate so that we can swap the behavior of this particular rock, paper, scissors player out on demand. Does that make sense? That's kind of the whole point of using the strategy pattern, is allowing us to easily swap different behaviors in and out of our programs. So, you know, we should probably code up a little something that uses this. Let's drop a main in here and play a little game of rock, paper, scissors. In order to do this, right, I'd have to create at least one of each strategy and then two different players. So the way that I can do this is I can say RPS player 1. Oops. And I need to pass a strategy into it. For each of our strategies, because they're so simple, I said I could use the default constructor, so I can actually just say something like this. Oops, it already did it for me. There's kind of a lot going on this line. I created a new object and immediately just passed it to another new object. In the next week or so, we'll see how to maybe clean this up a little bit. I'm not going to talk about that today, but for now, this works just fine. And then we'll create a second player that uses our random strategy. Player 2. And then we just need to have them go at it, right? Have them choose their moves and start playing. What do we want to do? Best of 5? I missed the semicolon. We just need to pick out the moves, right? So player 1 dot next move. I do the same thing for player 2. And then I just have to compare them. This is actually great leading to the second kind of subtopic I wanted to talk to you about today. I need to compare these two strings, right? Rock beats paper, paper beats, or I'm sorry, rock beats scissors, paper beats rock, scissors beats paper. And we need to track ties too, right? So I need to compare these strings somehow and see what they are, right? This if statement actually gets kind of big, kind of clunky, which is unfortunate, but we'll deal with it, right? How do I compare strings? Some of you, I think, have already run across this problem. It's real tempting to say something like this, right? If I want to detect ties, for example, if they're equal, right, I want to say, you know, they're tied. What's wrong with this? Anybody know? Will this work? Well, it won't. Usually it won't. Usually it won't. So the problem with this, double equals is great. Double equals only works for what we call primitive types. And primitive types are the things like integers, things like booleans, things like doubles, right? Those are going to be our primitive types. If we have objects, more complex types, of which string is an object, you can tell because the first letter is capitalized. We talked about naming conventions on Wednesday, right? If I see a capital letter in front of a type, that means it's actually an object. It's not a primitive type. So double equals, I can still use it, but it's not doing what I think it's doing anymore. Double equals in this case is saying, is this actually the exact same object as this object over here? Or in other words, right, I can have two strings that contain the exact same stuff, but these would not be considered double equal. If I use double equal on these strings, they would not be considered true. The value is the same, but they are two separate objects. I have two objects that happen to contain the same information. Does that make sense? It's a kind of a subtle distinction to make. The information in the object is the same. They are not the same object. They are two separate objects. So double equals is asking the question, is this the exact same object as what's on the other side? It's not looking at the contents of those objects at all. It's saying, is this the exact same thing? So if I wanted to make double equals true, what I could do is something like this, right? That would evaluate to true with double equals. S is now equal to S1 because I didn't create a new string for S1. I simply pointed it at S. I know you guys thought we were done with pointers, right? But actually, no, there's still pointers in Java. You just don't really see them. They're kind of underneath this, underneath the hood, behind the scenes. Double equals just compares the memory address. Yes, exactly. That's exactly what's happening. If these both reference the same place in memory, double equals will be true for objects. So that kind of gets us to our next question. Like, what if I actually want to check the content? I actually want to know if the content of these things are equal or not. How do I do that? Has anybody come across this? Does anybody know the answer? It's dot equals. Exactly. Dot equals. So if you want to check for equality for content, you need to use dot equals. So this would be the case if it's a tie. Now the case, so we have two other cases, right? Player 1 could win or player 2 can win. We really only need to specify one of those two cases, but it's a pretty long conditional statement, unfortunately, because we have to specify all three possible winning conditions for player 1. So let's see. I'll try and make this as quick as possible. Player 1's move is equal to rock. And player 2's move is equal to scissors. So that's one condition, right? We've got two more to go. Let's see if I can just copy paste this a little bit, try and make this quick. And really, I should probably try to break this up into multiple lines, perhaps. Or need this 2 more times. Get the winner. What did I do wrong? Oh, I forgot the dot equals. That's what I did wrong. I just wanted to be able to run this and show you the different strategies. This line is long. I actually feel kind of horrible writing this line. I should probably split this up. It makes me feel bad on the inside. I mean, you're right. Player 1 is always going to be rock, so some of this is, you know, but I could easily create 2 players that have the random strategy, right? In which case, I need to be able to check all of these. So I did rock and scissors. I did scissors and paper. The last one I need is, what is it? Rock and scissors, scissors and paper. It'd be paper and rock, right? Paper beats rock. I do, thank you. I would have found that eventually, like when I tried to run it and it crashed. And so then the nice thing about this is, oh, did I forget my brackets too? The nice thing about this is I don't have to specify the condition again. I don't need a semicolon there. I need a bracket there. Because if player 1, if it's not a tie, and if player 1 didn't win, then by deduction we can assume that player 2 has won. So I'm not going to bother checking that again. And then I suppose just to make sure that this works, we should probably print out what their moves are so that we can see that I'm detecting this properly, and then we'll test it out. Player 1 move. Probably make it a little bit better than that, even though we know what player 1's going to play every time. This again for player 2, and then we'll be ready to start our rock, paper, scissors battle. Okay, I think we're ready to test this out. Cool, let's try it. So we should see player 1 play rock all the time, and player 2 is just going to do its own thing. Player 1 played rock all the time. We've got a tie. Again, no surprise. Player 1's still choosing rock. Player 2 got lucky, playing rock. So what was that? 2 wins for player 2, 1 win for player 1, and 2 ties. So playing rock is not a very good strategy. You probably already knew that. I mean, it's a good strategy sometimes. Everything in moderation, right? So it looks like it worked, and we can see player 2 looks like it's randomly choosing, right? So that's the strategy pattern in action. The other thing I wanted to kind of come back to in regards to equals, one final little topic on equals, is if you want to check the equality of classes that you write, then you need to write an equals method yourself. So if I wanted to check 2 rock, paper, scissors players, for example, and see if they are equal, then it's to my benefit to write an equals method myself. Every object has an equals method, actually. So here's some good information for you. We talked about inheritance. Every object you create in Java inherits from a base class called object. And that object base class contains a method called equals. So when you're creating this equals method, you're not actually creating it, you're overriding it. And actually, this is such a common thing to do that typically I won't write it out myself. There's typically a way to have IntelliJ do it for you. Let's see if I can find where that is, because there's so many different options. Generate. Here we go. Equals, and it's cousin hash code. It wants me to, so if I want to compare if two things are equal, right, I have to select what I'm going to compare to see if they're equal. In this case, I'm going to refer to my instance variables, my properties. I only have one property. That's really all that I can check, right? If I had more properties here, then I could choose which properties I wanted to use to determine equality. It might make sense that in some cases that not all properties will matter when determining equality. It could be the case. A common example is dates. Let's say I have a date class with a month, a day, a year, etc. And maybe there's another property that indicates whether that day is a holiday or not. Well, if I say two dates are equal, I don't really care if they're holidays or not, right? They need to be the exact same month, day, year. Whether they're a holiday is very subjective and perhaps irrelevant to testing equality. In this case, we just have the one property, so there's not really much else we can use to do this. So you see that IntelliJ has generated this code for me. It uses ternary operators, which we haven't talked about. It's like an if statement, basically, a simplified if statement. And then to go along with equals, you'll typically see hash code included as well. You guys are familiar with hashing, right? You saw that with hash tables. Hash codes can be used to help test for equality as well. Consider I can turn anything I want to into a number. So if I take this object and I take this object and I run it through a hash function and the same number pops out on the other end, then they must be the same object, right? That's part of the properties of a hash function. So you'll commonly see equals and hash code used in conjunction with one another. But again, I would never sit down and type this code out. I'm gonna let IntelliJ handle that for me every time. So if you want to take a look at this code, or I'm happy to sit down and take a look at this code with you and walk through it step by step. I think you'd be able to figure enough of it out on your own. Honestly, you guys are sharp, and there's not a whole lot of new stuff here. But yeah. But where are those characters in the string class? Where are those stored? An array as a property of the string class, yeah. I mean, what else do you have to base it off of? I can't compare methods, right? All I can compare are things that physically exist, like properties. So yes, equals will be based on properties, yeah. But IntelliJ makes it real easy. Choose the properties that you want to compare. It'll generate the code to check those properties for you, and there's really no other effort needed on your part. This is what it's comparing to. I'm equal to what? What am I equal to? Or what do you want me to see if I'm equal to?
Okay, so you can send that
right, so everything, so here we go. This is a great question. Everything in Java inherits from the object base class. So I can treat everything as an object if I want to. Everything, because everything in Java inherits from the object base class. You see that part of what it's checking is the class, the actual class. So this is saying, okay, I understand object is your base class, but what are you really? Are you a string? If you're a string, then you're going to get string back here, right? And it compares that against the class of the actual object. So it is checking the subclass, the derived class, to make sure that that is equal, right? Making sure that they actually do share the same class. But I can compare any two objects that I want, right? I don't just have to compare strings with strings. If I wanted to, I could try to compare a string to a rock, paper, scissors player, or compare a string to a student, or compare a string to a course. Yeah, sure.
there that goes with, so this, the get class, the class there, this is the same as this class.
Correct, it is. Yes, that's the same as this .get class. In fact, I disagree with the IDE. I would have included it. Yep. Where did this method come from? I didn't write that method. Where did it come from? It came from the object-based class. Yes, exactly. It came from the object-based class. Yep. No, it'll come out as the actual class. It won't come out as object. Unless it actually is an object, unless it's not anything else. Yeah. So you can see there's actually a lot of inheritance going on behind the scenes here. Equals this is an override, right? It's implemented in the object-based class. We're overriding it for our own purposes. Get class is the same way. I think it's great. I think it'd be great if you take a look at the object-based class sometime just to see what's available to you. You've actually already seen some other methods in the object-based class. ToString is in the object-based class, and you've overridden that one as well. So you've been using inheritance, right, since day one. You just don't really realize what it is until you dig in and get your hands dirty a little bit with it. Any questions I can answer right now? I think that's about, yeah. Sure. Uh-huh. Right. Yes, it defines behavior. Yep. Mm-hmm. Uh-huh. Client maybe is the best term I can think of that accepts a strategy. That may not be the best word. It's the first one that popped into my head. I'd call this the client that utilizes a strategy. Yep. And so on pset 4, when you get around to working on pset 4, you guys did some sorting stuff in CS50, right? There's lots of different ways you can sort. Lots of different ways you can sort. So you're going to create a strategy pattern that allows you to swap out different sorting algorithms. You'll create an interface that defines the sorting behavior. You'll implement that interface. You'll implement that sorting behavior for what? Bubble sort, insertion sort, merge sort. Did you guys see merge sort? Yeah. You'll get to do those over again in Java, which should not hopefully be that much different than how you saw it in C. And then create a client that can sort arrays and actually compare how fast they are. That'll be kind of a race of strategies. So that's what you've got to look forward to for problem set 4. Are there any other questions for me right now?
What was the book you referred to?
The book I referred to at the beginning. Oh, yes. It's called Design Patterns. Design Patterns is the name of the book. It's also the concepts that we're talking about, yes. The authors are commonly referred to as the Gang of 4. If you search for Gang of 4, Google will know exactly what you're talking about. If you can get your hands on a copy of that book, it would be highly recommended. I believe Chris may have a copy floating around somewhere. Maybe not. I don't. Okay, yeah. It'd be a good resource. Especially as you go over the next few problem sets. And I have a copy too that I can try to remember to bring in. I should have brought it in today. Yep. All right, that's all I had for you guys.